All right. Hello, everybody. Here's some examples that use properties of definite integrals. So we're looking at a graph, and it has three shaded areas, A, B, and C. It tells you where the intercepts are. Basically, it's telling you they are where it looks like they are, and so we don't have to read that. The area of the region A is 4, so I'm just going to mark it here. Area of the region B is 6. I'm just going to mark it here. And area of the region C is 10, and I'll mark it there. So we don't have to keep referring back to that. We're going to answer these 6 questions. So here we go. The first one says, what's the integral of this function from 4 to 4? Now that's a very simple one because anytime you're taking the integral and the upper limit and lower limit are the same, that would be 0 because there is no area. And that's what this integral is trying to calculate. So that's a property. Easy enough. The second integral from 2 to 10. So here is 2, and here is 10. When you integrate from left to right, the integral will calculate the areas. If it's above the x-axis, it will calculate as a positive integral. So from 2 to 6, you have 6. But then from 6 to 10, the area is 10, but the integral will calculate as negative. So we have 6 plus a negative 10 or negative 4. Easy enough. So that's also using the property that the integral from 2 to 10 is the same as the integral from 2 to 6 plus the integral from 6 to 10. The third one, the integral from 2 to 10 of this. So this is going to be kind of easy since we just did question number 2. Negative f of x would flip this whole graph upside down. But you don't have to look at it that way because one property for integrals is we can factor out a constant. So that negative in front of the x is like a negative 1, so it's a constant. So this would be an equivalent integral. So this integral would be the same thing as negative this integral from 2 to 10, which we already did. So we already figured out that the integral from 2 to 10 was negative 4. So this is negative 4, which makes our integral positive 4. So those are the first 3 questions. The next 3 questions, what's the integral from 2 to negative 2 of 4 times f of x? Now there's different ways you can do this. Most definitely I'm going to factor out the 4. And then from 2 to negative 2, that's starting from here at 2 and going backwards to negative 2. So the normal integral will calculate this area of 4 as negative since it's below the x-axis, but since you're going from right to left, that negates that. So if the normal integral would be negative, if you're going backwards, it would make it positive. So this integral would be a positive 4. So our answer is 16. Now, another way you could have accomplished that is if you don't like going backwards, let's go forwards. We could, and remember the answer is 16, so we're going to get the same answer. If you want to flip the limits of an integral, you can, as long as you make the entire integral the opposite. So you can do it this way. Now the integral from negative 2 to 2, now we're going the normal direction, left to right. That would be negative 4 because the area is below the x-axis. So this answer would be negative 4 times negative 4, or 16, as we said before. So that was question number 4, done in 2 slightly different ways. Neither of them, I think, is easier than the other. It's just how you choose to look at it. Let's look at number 5. Uh, Number 5, I'm going to, once you look at that and you notice that the limits are kind of in reverse order, and you have a negative out there, I'm going to just flip the limits and negate the integral, which would make this negative positive, and also factor out the 2. So I'm going to do that all at once. So I'm flipping the limits so we can go as we normally go from left to right. That would make this negative a positive, and then the 2 I want to keep factored out. So this is what number 5 would look like. And now the integral from 6 to 10, from here to here, we're going the normal way now, left to right. Since this area is below the x-axis, that would calculate it to be negative 10. So the answer here is 2 times a negative 10, which is negative 20. That was 5. Question number 6 is probably the most difficult of all these because it has a minus 2. To do that one, there is really no property of integrals like we did with multiplication. You could factor out a constant. The negative 2 is not a constant here. It's just another term. So the one property we know about integrals is the difference. The integral of a difference is the same thing as the difference of the integrals. Now, you may think of that as like distributing the integral, which is not a really good mathematical way to say that. But that's what it looks like we're doing. So now you have this simple integral minus this integral that I don't think we can get from the graph. So let's do the simple integral first. The integral from negative 2 to 2, from here to here, is negative 4 because 4 is below the x-axis. Now, the integral of 2, you have to figure out what the graph of 2 looks like. This is the easiest way to do this. So the graph of y equals 2, and as you practice these, you don't have to draw this out. You'll get used to it. But y equals 2 is a horizontal line at y equals 2. So it looks like this. So when you're integrating this from negative 2 to positive 2, do you see how I'm ignoring this graph here during this integral? Because the graph has nothing to do with the integral of 2. Anyhow, going from negative 2 to 2, I'm just calculating this area. And it turns out to be a rectangle, and rectangles are easy. It's length times height, or it's 4, and this is 2. So it's 4 times 2, which is 8. Now, as you get used to this, you can just take this number multiplied by the difference between these two numbers, which is 4. So 2 times 4 is 8. But so our integral is from the first one, negative 4, this minus, and the integral of 2 from negative 2 to 2 was 8. So it's negative 4 minus 8, which is negative 12. So hopefully that makes sense. Hopefully I did them all right. Let me know if you disagree with anything. And I will see you next time.